Friends, good evening. Today we are focusing to discuss net previous questions that are asked from classical mechanics part 1, right? So let us start with the first question. An object is dropped on a cushion from a height 10 meter above it. On being hit, the cushion is depressed by 0.1 meter. Assuming that the cushion provides a constant resistive force, the deceleration of the object after hitting the cushion in terms of acceleration due to gravity g is. So the question is, you have a cushion here, right? So this is flexible cushion. Suppose a body, an object that is falling here. So this cushion will produce a depression of 0.1 meter, right? So 0.1 meter, and then this velocity becomes 0. What is the velocity at this point, right? So here the velocity is 0. This is the final depressing point. So the ball velocity becomes 0 and then again come back, right? So here the velocity is 0. And what is the velocity here? That is, it falls a height h, right? So what will be the velocity at the end just before hitting here? That is root 2gh, right? Root 2gh. We already know v square minus u square is equal to 2g h, right? So that is initial velocity is 0. So the final velocity is v square, that is equal to root 2gh, right? So it is falling a height 10 meter. So that is v square is equal to root 2 into g into 10. So that is root 20g, right? Now we can apply this equation here. This is my initial velocity, this is my final velocity, right? So again v square minus u square is equal to 2as, right? So this a is deceleration because it is going to, its acceleration is going to decrease. So right, so what I can say, that is this initial velocity, so deceleration, there is a negative sign. So v is 0, and what is u square? Root 2gh the whole square minus 2as. Now what is s? S is equal to, so we are asked to find a deceleration, right? Acceleration is equal to, so this is equal to root 20g, right? Initial velocity, so root 20g. So 20 minus 20g equal to minus 2 into a into s is equal to 0.1, right? So what is a is equal to minus 2 cancel, 10g divided by 0.1, that is 100g, right? So option C is correct, right? All right. Now let us go to another question. A ball of mass m is dropped from a tall building with zero initial velocity, right? In addition to gravity, the ball experiences a damping force of form minus gamma v, all right, where gamma is the instantaneous velocity and gamma is a constant. V is the instantaneous velocity and gamma is a constant. That means the resistive damping force is proportional to velocity. Gamma value is given, mass value is given, and g you have to take ton. The distance traveled in meters in t seconds, that we need to find. All right. So let me write the equation of motion for this. The net force acting on it. So suppose a body is dropped from a height. Its net force is ma. Ma is equal to, what are the different forces? Mg is acting downward and the resistive force is upward. Right. So that is ma is equal to, what I can see, then effective force is mg minus that is kv. Sorry, gamma v. That is what is m? M is equal to, that is given 10 into, what is a? That is d square x by dt square, plus what is gamma? Gamma is 10, that is given 10 into v is dx by dt. So I have taken this term to here. And what is m again? 10g. So you can cancel 10 here. Again differentiate. We can, this is a g is a constant, right? So d cube x by dt cube plus d square x by dt square is equal to 0. Now we can solve auxiliary equation m cube plus m square is equal to 0. That is m square into m plus 1 is equal to 0. So we have two roots 0, 0 and m is equal to minus 1. These are the roots of this equation. So how can we write the solution? These are the same roots. So c1 plus c2t into e raised to 0 t plus due to this we have c3 e raised to minus t. Alright. So this is the solution for x of t. Right. So we have already know how to solve this kind of differential equation using. We have already discussed in mathematical methods in physics, right? Okay, so I am not going to deep into this. Now this is x of t, so I can write x of t as c1 plus c2t plus c3 e raised to minus t. Right. What is x dash of t? X dash of t is c2 plus c2 minus c3 e raised to minus t. What is x double dash of t? That is minus c3 e raised to minus t. Alright. Now look into this three equations. So if I take t is equal to 0 in the first equation, before starting the motion, its displacement is 0. It is at the initial point, right? So 0 is equal to, if I give 0, t is equal to 0 here, the first equation x of t is 0 because no displacement. That means c1 plus c3. c1 plus c3, right? Now if you start with t is equal to 0 here, that is x dash of t means initial velocity. Initial velocity is 0, right? So this term also becomes 0 and that is c2 minus, t equal to 0 means c2 minus, and here we have c3. And again, what is at t is equal to 0, what is acceleration? Acceleration is acceleration due to gravity, right? It is under the gravity. So g is equal to, that is 10. G is equal to 10. X double dash of t is equal to 10. That is c3. So c3 is 10. If c3 is 10, what is c2? C2 also 10. Then what is c1? c1 plus c3 is 0. So c1 is minus 10. Right. Now we can substitute everything in our first equation. Right. c1 is equal to minus 10 plus c2 is 10, that is 10t, and c3 is again 10 e raised to minus t. So this I can write as 10 into t minus 1 plus e raised to minus t, right? So which one is the option? Option B is correct, right? All right. Now let us come to another problem. A cyclist weighing a total of 80 kg with a bicycle pedals at a speed 10 meter per second. She stops pedaling at an instant which is taken to be t is equal to 0 due to the velocity dependent frictional force. Her velocity is found to vary. The velocity equation is given 10 by 1 plus t by 30 meter per second. This is meter per second velocity and t is measured in second. When the velocity drops to 8 meter per second, she starts pedaling again to maintain a constant speed. Alright. The energy expended by her in 1 minute at this speed is. So at this speed, what is energy expended? That is force into displacement, right? So what is the, with this speed in 1 minute, right? 8 meter per second in 1 minute. What is the displacement? That also we can calculate. That is 8 into 1 minute. What is the displacement? 1 minute is 60, right? So 480, right? So we have what we need to solve the force. All right. What is the force? Force is equal to ma, right? F is equal to ma. That is m into dv by dt, right? So that is m into what I can say, that is 300 by, right, minus 300 divided by differential of this, that is 1 plus t by 30 the whole square, right? So that's why I am writing this t by 30 on doing we have a 1 by 30 here, right? So this whole square. So how can I write this? Minus 300 divided by t plus 30 the whole square. We can write like this. What is mass? Mass is equal to 80, that is given. So that is into 80. Now this is my force, right? We can differentiate this m into dv by dt. That's only I have done here. Now this I can write as we can write this in the terms of this, right? 30 plus t. So what is v of t here? That is that I can simply 30 plus t by 30, that is 300 divided by t plus 30. We can write like this. Okay, so if I write this as minus 4 by 15 and this whole square, we can write this as like this, v of t the whole square. So for minus 4 by 15 into this v of t the whole square, if you do, you will get the same, right? You can write this force. I have written simply, right? Now we can find out this as minus 4 by 15 v of t whole square into this 480. That will be the work done. Okay, so now you can substitute uh, and you can give t is equal to 30 in the v of t expression, right? So we can simplify this, then you will get the answer as 8 kg, right? 8 kilojoule. Okay, now let us come to another problem. A particle of mass m moving along x direction experiences a damping force minus gamma v square, where gamma is a constant and v is its instantaneous speed. The speed at t is equal to 0 is v0. The speed at time t is, right? So we can write the equation. Damping force is given, right? So we can write as this damping force equation m dv by dt is equal to minus gamma v square. That is dv by v square is equal to minus gamma by m dt, right? So we can integrate on either side. So what I have, minus 1 by v equal to minus gamma by m t plus c. Now when time t is equal to 0, there is no damping force, right? Time t is equal to 0, v is equal to v0, initial velocity. That is given in the question. So minus 1 by v0 is equal to c. Now we can substitute this here. Minus 1 by v is equal to minus gamma by mt plus 1 by v0. We have to find the speed at time t second, right? So what I can say, at t is equal to, so we can simplify this, right? Gamma by m t is equal to 1 by, right? So we can simplify this as, so let me use gamma by m t is equal minus gamma by m t minus 1 by v0 is equal to 1 by v. We are asked to find v, right? So v0 gamma t minus m divided by m v0 equal to 1 by v. So we can write v is equal to mv0 divided by, right? mv0 divided by Okay, so mv0 divided by v0 gamma t minus m, right? So this is the option we have. But we made a slight mistake here. We got C as minus 1 by v0, right? So we have to write minus 1 by v0 here. So this become plus, right? So the answer will be plus. There is no minus here. So this will be plus. So which one is the option? Option C is correct, right? All right. Now let us have another question here. An annulus of a mass m made a material of uniform density as inner and outer radii A and B respectively. Its principal moment of inertia along the axis of symmetry perpendicular to the plane of annulus is. So we have an annulus of mass, right? Like this, right? So its inner radius is A and outer radius is B. Now we are asked to find a moment of inertia perpendicular to the plane. So moment of inertia, to calculate the moment of inertia, we have to find solve the equation I is equal to integral dm, right, x square, right? Now this, what is this mass? Mass is equal to dm is equal to, so if I consider a small elemental strip in this, mass per area is, its area is b square minus a square into, if I consider a small elemental strip within this, so that is 2 pi x dx, right? Its area is 2 pi x dx, right? It is pi x square, and its a differential small area is pi x square, and dA is equal to 2 pi x square dx, right? Now we can substitute this value here, and this area of this small strip I am considering here, that is varying from A to B, right? Mass distribution from A to B. So A to B, m by b square minus a square 2 pi x dx into x square. Now we can integrate this that is equal to, right? So sorry, here we have a pi mass into area pi b square minus, so pi and pi cancel, this pi and this pi cancel, and we have a 2 here, and that is m by b square minus a square into 2, and here x cube dx, that is on doing x raised to 4 by 4, that is a to b. All right, now we can do integration, that is equal to 2m by b square minus a square into 4, we can take out, cancel with this 2, and this is b raised to 4 minus a raised to 4. This I can write as a plus b into a minus b, then this part and this part will cancel, we have b square plus a square here, that is m by 2 into b square plus a square. So which is the option? Option D is correct, right? All right, now let us have another question here. Two bodies of equal mass m are connected by a massless rigid rod of length L lying in the xy plane with the center of the rod is at the origin. If the system is rotating about the z-axis with the frequency omega, the angular momentum is. Alright. So as per this question, two masses, equal masses connected by a massless rod of length L. So about the center, this part is L by 2 and this part is L by 2, and it is rotating about this z-axis, right, with an angular velocity omega. Now what is the moment of inertia? That is m into L by 2 the whole square plus m into L by 2 the whole square, right? That is ml 2 ml square by 4, that is ml square by 2. And what is this angular momentum? L is equal to I omega, that is ml square by 2 into omega, half ml square omega, right? So option B is correct, right? All right. That is a simple question. And we have another question here, that is a pendulum consists of a ring of mass m and radius capital R suspended by a massless rigid rod of length L attached to the rim. When the pendulum oscillates in the plane of the ring, the time period of the oscillation is. So we have a pendulum consists of a ring, right, of mass m and radius capital R, suspended by a massless rigid rod of length L. So this part is length L and this ring radius is capital R, right? So this ring mass is capital M and this L is massless, right? Okay, this string is massless. Now the time period, it is a compound pendulum. So obviously you can use I is equal to 2 pi root I by mgr, right? So what is this center of mass location? So this is fixed at r plus L distance, right? The center of mass and this small r is equal to the position between fixed point and center of mass position, that is r plus L. And what is moment of inertia of this system, right? What is the moment of inertia of this system? That is the moment of inertia through this axis, right? So it is rotating like this, right? So about the diameter is that is mr square plus, right? It is a ring, right? What is the moment of inertia? Suppose it is rotating about this when the pendulum oscillate in the plane of the ring, right? The time period of oscillation, it is oscillating in the plane of the ring, right? So what is the moment of inertia of this system? That is mr square plus, that is the moment of inertia through this ring, right? And this is at a distance L plus R, so m into L plus R the whole square, right? So I is equal to, this is moment of inertia, sorry, this is time period, I am writing 2 pi root by mg into what is R? It is the separation between this fixed axis and the center of mass position, that is L plus R. Now you can simplify this, that will be the final answer, right? Then t is equal to 2 pi root, we have mr square here this whole mr square plus, we can cancel out all the m, so we need not this m, this m, this m. Here r square we have, here L square plus 2 LR plus R square divided by, here we have G into L plus R, and this again 2 R square plus 2 LR plus L square. So this will be the answer, alright? C is the option. Now let us come to another problem. Two masses M each are placed at the points XY, that is AA and minus A, and two masses 2m each placed at A minus A and minus A. The principal moment of inertia of the system are. So the expression for principal moment of inertia is, what is Ixx? Ixx is equal to sigma mi into yi square plus zi square, right? So that is, for the first case, this mass is equal to m. So m into this z coordinate is 0, y coordinate is a square, right? plus a square, and the second mass also is m, and the coordinate is again m into minus a the whole square, right? That is again a square, plus for the mass 2m, it is 2m into a square and 2m into a square. So 2m a square, 2m a square, that is 6m a square, right? Ixx. What about Ixy? Ixy is equal to, what is the value of Ixy? So that is equal to minus sigma mi xi yi. That is equal to yx also, right? So that is minus mi into, that is m, right? When you solve that, minus m into xiyi. So xiyi, a into a square, plus and this for the second coordinate it is minus a into minus a, that is again ma square, and for this it will be plus minus 2m into this product, that is minus a square, plus 2m into this product is again minus a square. So when you simplify this, here you have 2ma square, and this will be 2ma minus 2ma square minus 2ma square. So this will be 4ma square minus 2ma square, that is 2ma square. And z coordinate is 0, so izx equal to izy equal to I yz, okay, that is equal to 0, right? And what about this iyy is equal to, that also we can find out, that is sigma mi x square plus z square, and when you square this a square, that is so for the first part it is a square plus a square, that is 2a square, mass is common, so 2ma square, plus, and for the second thing, 2ma square plus 2ma square, that is 4ma square, that also 6ma square, right? So we can have all the values. Now we are able to write this izz also we can write. What is izz? Izz is equal to I into sigma mi into x square plus y square. So we have all the sum, that is 4ma square here, that means a square plus a square, 2ma square, 4ma square, so 4ma square here, and 2ma into 8ma square, that is 12ma square, right? So finally we can substitute all the values. So what is ixx value? That is 6ma square. Iyy value, that also 6ma square, and this will be 12ma square, and these coordinates ixx, then ixy, that is ixy is 2ma square, ixz, that is 0, and this term also 0, and this is yx, that is again 2ma square, and this 0, this 0. All right, now this is my moment of inertia matrix, right? But we are asked to find the principal moment of inertia, right? So we have to solve the characteristic equation. So determinant this matrix A minus lambda is equal to 0. So when you solve this, what you get? You can expand through this, that is 12ma square, right? 12ma square into so here all we have minus lambda, right? So 12 ma square minus lambda, all right, into this 6 ma square minus lambda whole square minus 4 2 ma square whole square equal to 0. So when you solve this, what you get? The value for lambda. You have three values. One is lambda is equal to 12 ma square, and when you solve this, lambda is equal to 6 ma square, and lambda is equal to 8 ma square. So principal moment of inertia about xy plane is this and this, right? So you can write 6 ma square and we have 4 ma square. When you solve this, 4 ma square and 8 ma square, right? So which are the principal moment of inertia, and this along z, right? These are the principal moment of inertia of the system, that is 4 ma square and 8 ma square, and this also a principal moment of inertia. But out of the given option, which are the possible combination? 4 and 8, right? So 4 and 8, that is B. All right. All right. So option B is correct. Now let us come to another problem. A ball weighing 100 gram released from a height 5 meter bounces perfectly elastically off a plate. The collision time between the ball and the plate is 0.5 second. The average force on the plate is approximately. So in this question, a ball, right, that is hit on a plate, and then if it is come with a momentum mv, it is leaving with a momentum minus mv. So what is the change in momentum? mv minus mv, that is 2 mv, right, divided by delta t, that is 2 m into what is this velocity? It is root 2 gh, right? Velocity is equal to, when it falls a height h, what is the final velocity? That is root 2 gh, that is root 2 into g, we can take as ton, right? What is height? Height is equal to 5, so root 100, that is equal to 10, right? M is 100 gram, so 100 into 10 raised to minus 3 into V is 10 divided by delta t is 0.5. So when you do this, you will have 2 by 0.5, that is equal to 4 Newton. So this will be the force, 4 Newton. So option D is correct, right? All right. Now let us have another question here. A ball initially at rest is dropped from a height h above the floor, bounces again and again vertically. If the coefficient of restitution between the ball and the floor is 0.5, the total distance traveled by the ball before to come to rest is. All right. So during the theory section, we have already derived the total displacement covered, right, before it comes to rest is, that is in terms of coefficient of restitution. If it fall from a height h, right, if a ball is finally comes to 0, right, if the floor and this make a that restitution is given, right, 0.5, then h into 1 plus e square divided by 1 minus e square. This is the relation which we have derived, right, before come to rest. This is the total distance covered, that is h into what is 1 plus e, what is e? 0.5, 0.5 square is 0.25 divided by 1 minus 0.25. So this is h into 1.25 divided by 0.75, that is h is equal to 125 divided by 75, that is 5 by 3h, right? So option B is correct. So I'm recommending to watch my theory section video. There we have derived this expression. All right. Now another question is, a ball of mass m initially at rest dropped from a height h is equal to 5 meters. If the coefficient of restitution is 0.9, speed of the ball just before hits the floor the second time is. So the first time is, if a ball is the first time before hitting the ground, what is the velocity? It falls a height 5 meter. So root 2 gh, right? That is root 2 into g, we can take as 9.8 into what is h, 5, right? And when it hit, its velocity changes. What is that velocity? This is before hitting v. After hitting, the v dash become coefficient of restitution into this velocity, that is e root 2 into 9.8 into 5. Now this velocity after hitting, that will be same before, just before the second hit. It will continue with when it falls with a velocity, when it reaches whatever velocity here, that will be the velocity before it hit the second time this surface. All right. So e into this velocity, that is root 2 gh. Now we can solve this. E value is given. What is e value? That is 0.9 into this 10 into root 98. Okay, so this will be approximately 8.91 something. All right. So option C is correct. Now let us have another question here. That is the final question. After perfectly elastic collision of two identical balls, one of which was initially at rest, the velocity of both balls are non-zero. The angle between the final velocities, right, in the lap frame is. So after a perfectly elastic collision, two identical balls, one of which was initially rest. So what I can say, suppose initially there is an angle between these two, right? Okay, so suppose I am considering there is an angle between these two, and after collision also there is an angle between these two. This collision is perfectly elastic. Here suppose this is theta 1 and theta 2. All right. Now the final velocities, the angle theta between the final, right? So initially one ball is at rest. I'm sorry. So we can draw the situation like this. So we have two bodies. One is at rest, u is equal to one with velocity u and other with velocity 0. So u1, this has a velocity u and this has a velocity u dash. After hitting, one is going like this and other one is going like this, and we have there is an angle between these two, right? So what is that angle that we need to solve? So we can equate, suppose initial momentum of this is mu, right? So this identical balls, though it has also mass m, so it moves with a velocity v1 and it moves with a velocity v2. So what is the component of momentum? If this is theta and theta 1 and this is theta 2, so mv1 cos theta 1 plus mv2 cos theta 2, right? So I have equated the x-axis component of momentum. All right. And what I can say about this kinetic energy, half mu square is equal to, right? So that is half m v1 square cos square theta 1 plus half m v2 cos square theta 1 plus and we have this u square is equal to, you can find out a u here, right? A mass we can cancel, so v1 cos theta 1 plus v2 cos theta 2, right? So here, sorry, there is no plus sign here. So here this half m, half m, half m. So u square is equal to v1 square cos square theta 1 plus v2 square cos square theta 2. Now if I square here to find u square, we have some other terms here, right? So what are the terms? And also we can equate the sine component also. Suppose we have equated the cosine component, right? And here we have m v1 sin theta 1, and here minus m v2 sin theta 2. What is the sum? M v1 sin theta 1 minus m v2 sin theta 2. Y component, initially we have, there is no y component of momentum, so that will be 0, right? So here we have some other equation, right? So this equation and this equation, all right, we can solve that. Then what I can write? So here I can cancel out this v1 sin theta 1 minus v2 sin theta 2 equal to 0, all right. Now and also from this I can write as u is equal to v1 cos theta 1 plus v2 cos theta 2. Now I am squaring and adding this equation. Okay, what happens? v1 sin square theta 1 plus v2 square sin square theta 2, okay, minus 2v1 v2 sin theta 1 sin theta 2 plus I squared this, and now I am going to square this, that is v1 cos square theta 1 plus v2 square cos square theta 2, right, minus 2v1 v2 cos theta 1 cos theta 2 equal to 0 square plus u square, that is u square, right? Now let me erase this and simplify. Here we have v1 square common, sin square theta 1 plus cos square theta 1, that is equal to 1, v1 square, and here we have v2 square common, right? So sin square theta 1 plus cos square theta 1, that is 1. Here I have minus 2 v1 v2 common, so cos A cos B minus sin A sin B, right? So what I can say, so if I take a minus 2v1 v2 out, then what will be the so here we have plus, I'm sorry, conservation of momentum we have applied, okay. So minus 2v1 v2 we can take out, then sin theta 1 minus sin theta 2 minus cos theta 1 cos theta 2, then what will be the result? That is cos of A plus B, right? Theta 1 plus theta 2. So but we have the value, this part is 0, right? Because by kinetic energy conservation, u square is equal to half m u square is equal to half m u square is equal to half m v1 square plus half m v2 square. So half m cancel. So u square should be equal to v1 square plus v2 square. So this term should be 0. That means theta 1 plus theta 2, that should be equal to pi by 2. Alright? Alright. So which is the option? Option theta. That is the angle between the final bodies. That is, this is theta 1 and this is theta 2. Theta 1 plus theta 2 is equal to, that is theta. That is equal to pi by 2. So option A is correct. Alright? Alright. So this is all about this section, and in the next section we will start with the mechanics part 2. Okay, thank you.